Okay, we're going to try a couple of age problems. And I just have to put my headphones back on here for the microphone. There we go, almost forgot. We've got the sum of Lisa's age and her father's age is 67. So Lisa's age and her father's age, they total up to be 67. 3 times Lisa's age increased by 7 is her father's age. How old is Lisa? So in terms of our let statements, we're really trying to find Lisa's age currently. And as a second variable, we have her father's age. So we're going to write our let statements. Okay, so I'm letting x be Lisa's age and y being her father's age, and the sum. So we're going to add the two ages together to get 67. So we should have an x plus y. The two ages total to be 67 years. 3 times Lisa's age, so 3 times, and Lisa's age is x, and then increased by, that's a plus 7, and then we have the magic is our equals, and then her father's age, and her father's age is the y. So what we have here is our second equation, 3 times Lisa's age plus 7, increased by 7, is equals the father's age, which is a y. Okay, so those are our two equations. You're going to put those into Desmos. You can graph them and find the intersection point. And when I put that into Desmos, I got an ordered pair of 15, 52. And remember, x was Lisa's age, and the y is her dad's age. And so that makes Lisa 15 and her father 52, and we follow that up with a final statement. So therefore, Lisa is 15 years old and her father is 52. All right, question number 2. Bart is 3 times older than his dog. So that's currently. And then 4 years ago, he was 7 times older. How old is Bart's dog? So there's 2 ages we're keeping track of, Bart and his dog. And we've got really 2 time frames to keep track of. We've got currently and we've got 4 years ago. So when we're talking 2 different time frames, I kind of set this up in a chart to help me organize the information. So we've got Bart, and we have his dog, and I'm going to set this up a little bit of a chart. This will be now, and this will be 4 years ago. Okay, so this is just an organization tool that will help you put the information together. So currently, we could let Bart be X years old, and his dog would be Y years old. Now, if you think of Bart's age 4 years ago, you could take his current age and then just subtract 4 from it. So 4 years ago, Bart would have been X take away 4, and the dog, if it's Y years old right now, it would be Y take away 4. Okay, now Bart is 3 times older than his dog. So Bart's age right now, he's older, so he would need to take the dog's age and times it by 3, and I wrote 7 instead because I was looking at the wrong number. You're going to times that dog's age by 3 to make it equal to Bart's age, because Bart's the older one. It takes the smaller one times 3 to equal the older. Okay, so that's the first equation. Now, 4 years ago, he was 7 times older. So that's where the second column comes into play here for the second equation. We've got Bart's age 4 years ago was X take away 4. So 4 years ago, he was 7 times older than the dog. So he's going to be 7 times older than the dog was 4 years ago. Okay, so that's in terms of the 4 years ago. There's our 2 equations that we're going to solve using Desmos. These ones can kind of be tricky, so I find that the chart is a way to organize it as a time frame of now and time frame of 4 years ago. Okay, and once you've put that into Desmos, you should find your ordered pair. I found the ordered pair was at 18 and 6. So that means Bart is currently, Bart is the X currently 18 years old, and the dog is currently 6 years old. That's the X and the Y. That would have meant 4 years ago, if I do 18 take away 4, that would calculate to be, I'm just switching colors here, that would calculate out to be 18 take away 4 is 14. And then 6 take away 4 would have been 2. So if we check that, the BART is 3 times 6, which is the 18, and then 14 would equal 7 times the 2. So that does make sense for the question as a way to check. And then we write our therefore statements. Okay, we're going to look at our distance, speed, time problems here. The first question actually has a typo in it. I kind of skipped when I was transcribing my written notes over to my typing notes. I must have missed my place anyway. It says Flanders took a trip from Springfield to Shelbyville, a distance of like 830 kilometers. He traveled part by car, and then we want to insert this part in here. Traveling at an average speed of 60 kilometers per hour, and part by monorail, traveling, and then we go back into the question, at an average speed of 110 kilometers per hour. The total trip took 9 hours. How many hours did he travel by monorail? Okay, so with these questions, again, a chart sometimes is very useful for organizing the information. We want to know how many hours. So it's time that we're trying to solve for. And there is a relationship between distance, speed, and time. And you may have learned this little trick in science class, where you create this little triangle. And it goes alphabetically. D goes on top, and then S for speed. So D for distance, S for speed, and then T for time. So alphabetically starting at the top and then left to right like you would read a book. Now, how that works is that if you're trying to solve for distance, so I'm trying to solve for distance, I've colored that out. It leaves you with speed beside the time, and you know when you have two letters side by side, it just means to multiply. Okay, if I wanted to solve for speed, I have distance on the top of time, and that line is meaning divide, the line that's between them. So speed is equal to distance divided by time. And similarly, if I wanted to solve for time, I would do distance divided by speed, because distance is on top of the speed in the triangle. Okay, another way to think of that is on the side of the road, we know that we have a speed limit, and the speed limit is given in a unit of kilometers per hour. So on the top, kilometers is a distance, and on the bottom you have hours, which is time. So that speed we know is equal to kilometers divided by hours. So just another way to help you remember which way is which. Okay, we need some let statements here, but before we do that, we're going to organize our information in a chart. We're trying to find the time traveled by monorail, but he also traveled part of the trip by car. So I'm going to have two parts here. I've got car, and we've got, I'll just put rail for short here, rail. And then we're talking about distance and speed and time. And my arrow is kind of in the way, but I'll do D for distance, S for speed, and over here we'll put T for time. And then underneath, slightly extending this, we're going to put total. And we're going to keep track of some totals because I have some total. The total distance traveled was 830. It's not the distance for the car, it's not the distance for the rail, it is a total amount, 830 here. And we also know the total trip took 9 hours, so total time is 9 hours. And we're trying to solve for how many hours traveled by monorail. So I could let my variables be the times. The times could be the C for car and R for rail, or M for monorail. I'm going to go with X and Y because that's what I'm going to use in my Desmos. The other information I haven't included in my chart yet is the average speeds. So the car speed was 60 kilometers per hour, so I'm going to fill this in with 60. And the monorail had an average speed of 110, so it's going to go here. Now, based on that information, my distance is going to be equal to, distance is equal to speed times time. So my expression I could use for distance could be 60, try that one again, 60 times the time, which is X. And the distance traveled by monorail would be the speed you're traveling at, which is 110 kilometers per hour. 110 kilometers per hour, and then times by the number of hours, the time. So X represents the time spent traveling by car in hours, and Y represents the time spent traveling in the monorail in hours. So we should put our let statements in there, and then we'll come up with the equations. Okay, once we've got our let statements there, we can start building our equations. We know that the total time would be 9 hours. So if I look at what I have here in this column, my time is X and Y, and they have to total up to be 9. So my first equation, or one of my equations, could just be that X plus Y equals 9. And then I have another total equation where it's telling me that the distance traveled by car plus the distance traveled by rail has to add up to be 830 kilometers. So my second equation could be 60x plus 110y, so the distance traveled by one plus the distance traveled by the other has to equal 830. So there are my two equations I can solve using Desmos and write my therefore statements. All right, when I put that into Desmos, I then got 3.2, comma, 5.8 as my intersection point. So it's 3.2 hours, or 3 hours, and then 0.2 of an hour. If I want to change that to minutes, and this is a good thing to know, because we don't usually say, yeah, I drove for 3.2 hours. We don't say that. We drove for like 3.5 hours, or 3 hours and 20 minutes, or something like that. The 0.2 also does not mean 20 minutes. We have 0.2 of, and in math, of means multiply. And in 1 full hour, there are 60 minutes. So I've got 0.2 of the 60 minutes. So if you put that into your calculator, you are going to end up with 12. So he actually traveled 3 hours and 12 minutes by car. And then I can do the same for the 0.8, or I can subtract the 12 from 60, and we get 48 as an answer. So then we should follow that up with a therefore statement. Therefore, he traveled 3 hours and 12 minutes by car and 5 hours and 48 minutes by monorail. And actually, this question was only asking for how many hours he traveled by monorail. So for my therefore statement, I just put in the time for the monorail. Okay, try the next question and see how you do on that, and I'll post a solution for that one.